Hi guys, today we are going to be introducing our third and final way to graph a line. So we had talked about how to graph a line by finding ordered pair solutions or XY table. We had talked about how to graph a line by using the X and Y intercept, and today we're going to talk about my favorite way to graph a line, which is by using the slope and y-intercept. In order for us to graph a line by using the slope and y-intercept, then we need to make sure that our equation is in slope-intercept form, or y equals mx plus b. So friendly reminder, so m represents the slope and b represents the y-intercept. So let's do this. So fun problem. We have two short graphing problems and then we're good. Cool, so just bear with me. So it says write the following in slope-intercept form, then graph the line using the slope and y-intercept. So we are not given the liberty to graph however we like. We have to use the slope and y-intercept. So please be mindful of the direction. So slope-intercept form. So slope-intercept form, that's the y equals mx plus b. So like in English, solve for y and then put the x term first. So if you want to solve for y, if you're not with the y, you gotta go. Let's go ahead and do the addition. We'll subtract 9x from both sides. And that will leave us with 3y equals x term followed by constant term. Y equals mx plus b. So we got to put the x first. To finish it off, to get rid of the times 3, let's go ahead divide both sides by 3. And again, I discourage the long fraction bar. But if you want to use the long fraction bar, go for it. Just make sure you actually divide both terms by 3. But if you divide both sides by 3 by dividing each term explicitly like this, then you're not gonna make careless mistakes. Okay, so when we simplify, the 3's cancel out and that will leave us with y equals negative 3x minus 8. This is in slope-intercept form, so we're good. This is the first time that we're doing this, so I'm gonna write down what it means to be in slope-intercept form. Y equals mx plus b. So whatever the coefficient of x is, that's gonna be our slope, or m. So in this case, the coefficient of x is negative 3, so our slope is negative 3. B, that's going to be our y-intercept. Okay, so constant term is negative 8, so our b or y-intercept is at negative 8. B reminds me of nothing. I already have nailed that m is slope, but b is still fairly new, so I'm going to put y in for my peace of mind. So where should we start? M is not a point. You know, you can think of like directions to get a point. The slope is not a point, so the only point that we have is our actual y-intercept. Okay, our y-intercept is at negative 8. So where am I? Y-intercept is at negative 8. Let's locate negative 8 on the y-axis. Cool. Now, before I forget, bringing back our number sense, if our slope is negative, I'm like, is the line expected to point up, down, be flat, or be vertical? If our slope is negative, then our line is expected to go down. Okay, so now, let's apply the slope of the line to get to a second point. So remember, slope, ratio of rise to rod. So I made these fractions. So let's go ahead and write the negative 3 as a fraction, namely negative 3 over 1. So in this format, we're saying that our rise is negative 3 and our run is positive 1. So from whatever point we have graphed, we're going to go 3 down and 1 to the right. So 3 down, 1, 2, and I'm out of bounds. So we're going to have to write this slope a little bit different. So we wrote negative 3 as a fraction, so negative 3 over 1. And I know that you know that when it comes to negative fractions, you can put the negative sign wherever you want. You can put it with the top, with the bottom, or like right in the middle. Since leaving the negative with the numerator didn't work, let's go ahead and rewrite it and put it with the denominator. So we're going to write it as 3 over negative 1. So again, we are not changing the slope. Changing the slope means you're changing the value or its meaning. But in this case, we are just rewriting it because 3 divided by negative 1 still gives us negative 3. And we have to rewrite it because we're out of space. Okay, don't guesstimate your points. So in this new format, our rise is positive 3 and our run is negative 1. So we're going to go up 3 and then 1 to the left. So from our point, wherever we started at, let's go ahead and do this. Our rise is 3, so let's go ahead and count to 3. 1, 2, 3, and then our run is negative 1. So we're going to pull 1 to the left. So up 3, 1 to the left. We just need 2 points to do a line. We have our 2 points, so just take your ruler or straight edge. Okay, this is the slow part for me. Some students ask me, how long does my line have to be? Uh, I feel like that's like a weird question to me because I don't even think about it, I guess. But to me, I just do it as long as I can. Some students are like barely minimum, and I'm okay with that. As long as your line goes through those 2 points, you're good. Just make sure you put arrows at both ends, and then you're gonna get your full credit. Fantastic. So one problem down, one more to go, and then we're good for the day. Cool. So problem B. We have 4y minus x equals 0. So again, we cannot graph it however we like. We have to write it in slope-intercept form. Then we have to use the slope and y-intercept to graph the line. So let's go ahead, solve for y. So if you're not with the y, adios, you have to go. To undo the subtraction by x, let's go ahead, add x to both sides. And that will leave us with 4y is equal to x. Fantastic. To finish it off, to get rid of the times 4, let's go ahead, divide both sides by 4. And that will give you y equals x over 4. Now, if you want to leave it like this, that's fine, but this is not very helpful for me because I want to see what we're multiplying the x by, not what we're dividing the x by. So let's go ahead, write this as a multiplication problem. To facilitate the process, I'm going to enter the special effect 1. I call it special effect because it wasn't there, and surprise, it's there now. Okay, so when I enter my special effect 1, hopefully it'll make it easier for me to be able to rewrite it. So we're going to write this as fraction times x, namely 1/4 times x. So we have y equals 1/4 times x. So we're good. So we want to write this in slope-intercept 4. There is no constant term. It's okay. So let's identify the slope. So in this case, m, or our slope, is whatever the coefficient of x is, and the coefficient is 1/4. Since there is no constant term, then our b is 0. Now, what if you don't see it? Then pencil it in. I know that you know that adding 0 to an expression is not going to change the value of the expression. So when you pencil it in, then it's easier to see like, oh yeah, my b or my constant term is 0, so our y-intercept is at 0. So let's do this. Since our y-intercept is at 0, let's locate 0 on the y-axis. Okay. And then we apply the slope to get to a second point. Slope, ratio of rise to run. So, sorry, that was too close. Okay, so our rise is 1, so we're going to go up 1 unit. Our run is 4, positive 4, so we're going to go 4 to the right. So from our starting point, whatever point that may be, let's apply the slope. Up 1, 4 to the right. Up 1, and then we go 4 to the right. 1, 2, 3, 4. Cool. All right, we got 2 points. Let's take our straight edge, connect the points, and then we're good. Put arrows at both ends. You got this. Please don't get dinged on technical difficulties. Some of you may be tempted to freehand these lines and then, no, what do they say? No bueno. Okay, however that saying goes. I'm pretty sure you can do really straight lines, beautiful straight lines, but they will never be as straight as if using a straight edge, whether it be actual ruler, anything that has a straight side. That's my bookmarker. Okay guys, so I said we were going to do 2 problems. That's the end of that, so we're good. Thank you.